Hi guys, this is the third in the series of demystifying machine learning videos. Thanks for watching my video. Uh, in this session, let's begin with a quick recap of the definition of machine learning. Machine learning is a subset of artificial intelligence which uses statistical methods to understand and analyze data, which can improve user experience on certain aspects, such as prediction, classification, clustering, or whatever. Uh, on an uncertain input, if the system is able to make a decision which is close to a real life decision, that is nothing but the success of a machine learning is. So let's look through the steps in machine learning today. This sunset is taken from Bali, Indonesia, uh, in 2008. And believe me, this is an unedited image. I have just captured it in my regular digital camera, not even a SLR camera. Roughly, machine learning involves these 5 steps: gathering data from sources, cleaning data to have homogeneity, model building, selecting the right machine learning algorithm, gaining insights from the model's results, and data visualization, transforming results into visual graphs. So let me now expand this into a 7-step process, which essentially expands the algorithm, choosing algorithm, and running the test, training, and then tuning certain elements of that part. So if I expand this to 7-step process, which is essentially our focus for today in this video, it is gathering data and then preparing that data, choosing a model, training, evaluation, hyperparameter tuning, and prediction. The steps are taken from the given reference here in towards data science article. It's also there as a video by Google available in YouTube. Uh, but let me go out in my way. Uh, so rest of the slides data are taken from this particular URL. Credit fully goes to them. Now, our problem in this example is to determine whether a drink is wine or beer. This model answering system that we build is called, this question answering system, sorry, that we build is called a model, and the model is created via something called as training. So what is the goal of a training? The goal of training is to create an accurate model that answers our questions correctly most of the time. But in order to train a model, we need to collect data to train on. And that is where we begin. The first step is gathering data. So there are many aspects of drinks that we could collect data on. Maybe you could go to a nearby wine shop and purchase a lot of different beer and wine. Use some machines to test the color, texture, the amount of alcohol, and other details. It's all up to you. Or you may be able to collect similar data that someone else have collected already and published at a data set. Let's consider two simple features here. One is the color as a wavelength of light, and the alcohol content as a percentage for these two items. So the first step is gathering data, where we gathered different types of beer and wine, where we know the color as a wavelength of light, so in nanometers, and the alcohol percentage, and then the answer when the color is 610 nanometers and 5% alcoholic content, it was beer. When the color is 599 and the alcohol percentage is 13, it was a wine. So we collect data as much as we can. The quality and the quantity of data actually helps you determine how good your model can be. The second step is data preparation. Load our data into some suitable place and prepare it for use in our machine learning training. The first and foremost important step in data preparation is split the data into two parts: training and testing data. Typically people follow a 70-30 rule or 80-20 rule based on size of the data. When I say 70-30 rule, that means 70% of your input data is used for training the algorithm, and 30% is used for testing. So this is analogous to having certain problems solved in the class, for examples, to understand how to solve certain problem, and some different problem that is asked in the exam to test how much you are learned from the training. So same question being asked again is nothing but testing your memory. So the same problem happens here. So we initially itself segregate the data. You can do more to do with data preparation. For example, you want to randomize the input data so that it is not in any order. Uh, and if you have just got this data from elsewhere, you may want to validate to see there are some missing data or how to manipulate such missing data. There are a lot of things that you can do with data preparation. In our example, assume we went to a beer shop and got all these beer wines and we manually tested. So we have nothing missing, so let's proceed. Now the next step is based on the problem that we are handling. We may want to choose a model that the researchers have already created over the years. If none of them fits for your problem, you may want to even invent a new algorithm or modify an algorithm. So again, it depends on the algorithm. Choosing an algorithm depends on the type of data you have. For example, image data or sequences like music, numbers, text-based data. So based on the data, your algorithm may differ. In our case, since we only have two features, color and alcohol percentage, we can use a small linear model, which is a fairly simple one that should get the job done. So this is similar to what we have seen as given a height, determine the weight problem in the previous video. Now training. In some ways, this is similar to someone first learning to drive. For example, at first you want to learn driving, but you do not know how any of the pedals, knobs and switches work, or even any of them, how should we use them. However, after lots of practice, correcting the mistakes, after falling down a few times, a licensed professional driver emerges. And after a year of driving, you are extremely professional. You can probably participate in a racing. The act of driving and reacting to real world data has adapted their driving abilities, owning their skills. So the training is nothing but doing the same process. So we will do this as much on a much smaller scale with our drinks. Typically we use a straight line formula, y is equal to mx plus b, where y is the output, m is slope of the line, x is the input and b is a y-intercept. The values we have available for us for adjusting or training are m and b, where x is already given, y is something we want to obtain as an output. By modifying m and b, can we get an answer y which is as close as possible to the data that we already have in our training output. So for that, in machine learning, there are many m's since there may be many features. The collection of these m values is usually formed into a matrix that we denote as the weight matrix W. Similarly for B, there will be multiple biases. We arrange them together and call it as a bias matrix. The training process involves initializing some random values for W and B, attempting to predict the output, and initially, since you chose a random value, probably it will perform poorly, but we compare it with the model's prediction with the output that it should produce and adjust the values until we get to a sufficient amount of comparative answers. This process is repeated. Each iteration on or cycle of updating the weights and biases is called a training step. When we first starting the training, it is like we draw a random line through the data. Then each step of the training progresses, the line moves slowly, step by step, close to an ideal separation of wine and beer. Now the fifth step is evaluation. Once training is complete, we should check how the model is good. How good is the model? So if you remember, we have split the data into training set and testing set, maybe a 70-30 strategy. 70% of the data is used for training until the previous steps. And now the remaining 30% data we will use to test how the model will look like for those uh, data of color and alcohol percentage, for which how it determines whether it is beer or wine, and then we evaluate it with the answer we already have for the test data. Now once you have done the evaluation, it is possible that you want to see, do you want to further improve your training, which is essentially done through tuning our parameters. For example, one of the parameter, for example, is how many times we run through the training set during the training. Do we need to give some more trainings? Do we need to give another 10 rounds of training before we test again? So this can sometimes leads to higher accuracies. And the seventh step is, when we know our system works quite well, we'll put it into practice. We give a completely new input, the color and the alcohol percentage. The model should predict it as beer or wine. In this example, the color is 660 nanometer and alcohol percentage is 12%. The model that is trained, tuned and evaluated predicts this as wine. And hopefully this is correct with maybe 98% accuracy, assuming that was the accuracy we achieved during our evaluation. So to summarize, the 7 steps are: gather data, then process the data for homogeneity. The preparing data is a huge step, believe me, it is not easy. There will be missing data, there will be wrong data, there will be lot of uncertainties. We have to deal with all of them. It's a big process involved. And then choosing a model based on the type of the problem we are trying to solve, and then train the model using the data, and then evaluate how much our training was good, and then tune. Some of the steps may go back and repeat, and once the tuning is all proper, we start doing prediction. With that, let me thank you. I hope you are enjoying my videos. Please subscribe, like, comment, give your feedback so that I can improve more. Thank you very much. Have a nice day.